One practical problem facing many types of pumps is cavitation. Now, cavitation occurs when you have very low pressure on the backside of a blade in a pump. And when that pressure drops below the vapor pressure of the fluid, suddenly vapor bubbles can form. This can occur in any machine handling liquids. When the fluid then moves to a higher pressure area, the pressure goes back above the vapor pressure and the bubbles very suddenly collapse. And this results in very large forces because of these high-speed jets of fluid. And so if you do have this cavitation, you're using a lot of energy to produce this vapor and then collapse it rather than increasing the pressure, and it can drastically reduce the performance of your pump. In addition to this, the forces involved can actually cause significant damage to the blades, which of course is going to increase your maintenance costs. You have to replace the blades. So we really want to try to avoid cavitation whenever possible. It's very loud. You can hear when cavitation occurs because of the very loud noise that it produces. But this makes it also very important for things like submarines, which are trying to move quietly. You want to make sure you avoid cavitation in that case. The best way to avoid cavitation is to make sure that the lowest pressure inside your fluid machine is kept above the vapor pressure. So what that means is you need to keep the pressure at the inlet to the pump, or the suction, slightly elevated above the vapor pressure. So we call this net positive suction head, or NPSH. That's the difference between the stagnation pressure at the pump inlet and the vapor pressure of the liquid. So you have the inlet pressure plus the part about the velocity, so that gives you the stagnation pressure, and it's the difference between that and the vapor pressure, only expressed here in this equation in terms of head, right, with units of meters or feet. Now, the requirement here is going to depend on the fluid, its temperature, etc., the things that are going to change the vapor pressure. Net positive suction head required, or NPSH-R, is a fluid property, or a pump property, and it's determined experimentally. If you go back to our pump curve, you can see the line that's labeled NPSH required. So at different flow rates, as the flow rate changes, you need to have a higher net positive suction head in order to prevent cavitation in the pump. Now, net positive suction head available, or NPSH-A, is a system property. It depends on your fluid system, and you have to determine that via analysis or experiments. In general, it's recommended that net positive suction head available be at least 10% greater than net positive suction head required. This is to prevent small changes in flow rate from producing cavitation in your system, small oscillations. However, in critical applications like power generation or flood control, a margin of 100% or higher is often used to make sure, absolutely certain, that cavitation does not occur. Now, that means that it's good engineering practice to place pumps below any suction reservoir. So if you have a large tank of water and you want to pump water from that tank, it is much better practice to put the pump below the tank. The reason for that is when you place the pump above the tank, the suction pressure is reduced by the hydrostatic head. That reduces the net positive suction head available and can cause cavitation. When you put the pump below, the suction pressure is actually increased by the hydrostatic head of the fluid, and that helps increase the net positive suction head available and prevent cavitation.